Hey guys, RaiderGuy78 here, and welcome back to another video that's just math, nothing to do with Borderlands. And the reason I'm here is because I have a hunch, and it's concerning something with differential operators, the Taylor series, and the exponential function. So what is the Taylor series? If you remember from Calc 2, you know, that given a function that is continuous on order n, we can express this, and that's just going to say n goes to infinity, as a sort of sum. With, you take the degree of the polynomial, you take the degree as the order of the derivative, and you basically center it wherever you need it, according to this. And this here is a derivative order n. Excuse the poor handwriting. And I would like to relate this to a little something about the exponential function, especially to a certain someone I know, a Borderlands modder, who doesn't listen to my definition of the exponential. So the exponential, big emphasis on the, is this one with the base 80. And this has a very nice consequence with Taylor series, that the Taylor series for e to the x is just given by this, because it's its own derivative at all times. So you can just plug in, you know, this always works. But this also lets you compute some funny things. For example, you can plug in e to a complex power, e to a matrix, or, and here's what I'm thinking, e to an operator power, which is where I'm going to introduce the d notation, where I'm just going to have the d operator expressed as the derivative, or rather the derivative operator is expressed as the letter d. So where does this all come together? So e to the d gives us this operator, and this is an operator. If we look at the Taylor series, this gives us the expression d to the n over n factorial. And what does this look like? Well, this looks like just 1 plus the first derivative plus the second derivative over 2 plus third derivative over 6, and so on, all the way to infinity. And something to note about this operator is that it is not commutative. This is not true. dx, given that this is d of x, is just 1. This is x times d dx. So this is not commutative. We can have e to the d on the left to be operating on a function, or the function and then e to the d. And that gives me an idea. So if we look at the Taylor series, there's this derivative term, this part. So I'm thinking that we can just replace this part with the derivative at 0. So we just have x to the n d to the n over n factorial. And if we see this is operating on the function at 0, right? And what does this look like? Here's our input. Our input is xd. Yes, the funny. So I have a hunch, and I'm willing to bet that as long as this is operating on f of 0, but not the derivative of f of 0, but operating at the function evaluated at 0. So this is more like f evaluated at x equals 0, but just ignore this. That's just my abusive notation. That the Taylor series can be expressed as an exponential. That you can actually write this, since this is this is x of x, which is the same thing as e to the x, and that this can be written like this, or really the x0, whatever. You kind of got to know what this means. But you kind of just move this right here. So we can just have x equals 0. And that this is the Taylor series. And if you want to abuse notation even more, I am willing to bet, not really, not money, but I'm just saying it, that if anyone can show me to justify, I would love to know if this is the Taylor series. If you can show that this is the Taylor series of a function evaluated at x0, or really, I meant to write this as 0. Please, let me know. I've been thinking about this since I took differential equations a couple months ago, and this has been not bugging me, but I've just been curious, because if we know quantum mechanics, that e to the d is the shift operator. This is the shift operator. It moves a function. So maybe if we add an x in there, it turns it into the Taylor series. That shifting a function that the shift operator applied x times produces the Taylor series. Let me know.